Trigonometric identities is probably actually one of my favorite concepts and problems from trig content. I guess you'll make up your own decision about that as we go forward, but they're a little bit like puzzles. And I think one of the trickier parts about trigonometric identities is that they're going to require quite a lot of algebra. So I'll make sure that I try to go slowly through not only the trig aspect of the problems, but also the algebra aspect of the problems. So what I'm going to do at the beginning here is look at some simplifying techniques. Because again, what is going to happen is later you'll see you're going to have an equation. So you're going to have a left-hand side of an equation and you're going to have a right-hand side of an equation, and you're going to have to show how those equal to each other. And we normally only work with one side of the equation, and what you're going to do is you're going to have to use simplifying techniques to make it look like the other side. So just to begin, right now, I'm just going to practice with you the simplifying techniques that you're going to see often in trig identities. And what's really important here is, of course, anything with math or anything with science or anything in life, really, you have to practice to get better. But this is one of the cases where you really need to do as many as possible, because you will see often the same simplifying techniques over and over again. So the more you're exposed to them, the more you're going to recognize them. So the first one we're going to do is we're going to simplify tangent over secant. And we're going to do this by, again, doing something that is very, very common in doing trig identities, which is to rewrite everything in terms of sine and cosine. All right, so how we're going to do this is we're going to use our known trig identities from before. So that's going to include our reciprocal identities, our quotient identities, our Pythagorean identities, and so on. So what do we know about tangent? We know that tangent of theta is equal to sine theta over cosine theta. And we know this by the quotient identities. And we know that secant of theta is equal to 1 over cosine theta. And we know this by the reciprocal identities. So now what I'm going to do is I'm going to take tangent of theta over secant of theta, and I'm going to rewrite them using the quotient and reciprocal identities. So at the top is going to be sine theta over cosine theta. And then I'm going to do an even bigger line here, 1 over cosine. And the reason that I like to use the bigger line, the dark bolded line, is because there's a lot of fractions going on. So I like to do that to really show like this, my main fraction line. And then I have the top and I have the bottom. And then what we're going to do here to simplify is we're going to use algebra. And we're going to do what we normally do, which is when we divide by a fraction, we multiply by the reciprocal. So what I'm going to do instead is the top is going to stay the same, but this little guy right here, when I multiply it, when I bring it to the top, I take the reciprocal of it. So I switch the bottom and the top. All right? So what I'm doing here is I'm going to multiply by the reciprocal. But what happens here now is really nice, because the cosines, because everything is being multiplied, they cancel each other out right here. And so what I can do now is I'm just left with sine theta. So I started off with tangent over secant, but actually when you simplify it, tangent over secant just ends up being sine. So what I did here to do that is I use quotient and reciprocal identities of trig, and then I simplified it using algebra. Let's look at some other techniques. Okay, another very common simplifying technique you're going to use when it comes to doing trig identities is using a common denominator. So this is going to be very common when you have two separate fractions. And that's exactly what I have right here. I have 1 over 1 minus sine x, that's my first fraction. And I have 1 over 1 plus sine x, that's my second fraction. So I'm going to try to highlight it. So in the first fraction, this is my denominator. And in my second fraction, this is my denominator. So what I need to do is I need to do a common denominator where I need to multiply the orange version to the second fraction, and I need to multiply the pink version to the first fraction. So I'm going to rewrite it one more time here. And I'm going to save some space on the left and save some space on the right. I'm doing it on purpose. So on the left-hand side, I need to multiply by 1 plus sine x. And on the right-hand side, I need to multiply by 1 minus sine x. And if it helps, because technically, right, these are also in parentheses down here. And then I'm going to have my common denominator of the orange times the pink, right? So we'll do it one more time. So here's my pink. And here's my orange. So what is that going to do when I do the common denominator? Well, at the top, I'm going to have 1 plus sine x times 1. So that's just 1 plus sine x. And that's going to be over 1 plus sine x over 1 minus sine x plus, and on the other side, I'm going to have 1 minus sine x. Oops, I don't want to do a parentheses here. And then here I have my common denominator again. Right, so what I did here was a common denominator. And I'm going to keep writing it because you'll see when I go to the other identities, I'm going to write out my reasoning for every step just to make it super clear. So now the whole purpose of doing a common denominator is that you can combine it into a single fraction. And technically, if you wanted to, you could have done that in the step I just wrote. I'm just really trying to take it slow with the algebra. But if you are comfortable with that, you could have done it at that step. So what I'm going to do is I'm going to create one fraction, and I'm going to combine the top together. So I'm going to have 1 plus sine x plus 1 minus sine x. So I'm going to go over here. And at the bottom, what I'm going to do is I'm actually going to FOIL, okay? So I'm going to multiply the purple and the pink together. So how are we going to do that? I'm going to, right here, actually, give me a second. I'm actually going to put it right down here to make it a little easier, and I'll move the common denominator. So how you FOIL is you need to distribute twice. So I'm going to do it first in blue. So I'm going to take the 1 and distribute it to the 1 and distribute it to the sine x. And then I'm going to take the sine x and distribute it to the 1 and distribute it to the negative sine x. So foiling is just distributing 2 times. So when I distribute the 1, I'm going to distribute the 1 to the 1. Well, 1 times 1 is 1. And I'm going to distribute the 1 to the negative sine x. So that's a negative sine x. So that's my first distribution. Now I need to do the red distribution. So I'm going to do the sine x times 1, which is a positive sine x. And then I'm going to have a positive sine x times a negative sine x. So a positive times a negative gives you a negative, and 2 sine x gives you sine squared x. Remember, like x times x is x squared. Sine times sine is sine squared. So this is going to give me a positive sine squared x. So that's foiling the purple and the pink together, and that's my common denominator, right? Because if I'm foiling on the left fraction, I'm foiling on the right. They have the same denominator. So now we're going to simplify that, the top and the bottom. Well, in the top, I have 1 plus 1, which is 2. And then I have a positive sine x and a negative sine x. So they actually cancel each other out because one's positive and one's negative, and they're the same. In the bottom, I have 1, a negative sine x and a positive sine x. So again, they cancel each other out. And then I have a sine squared x. But remember here, I'm going to have 1. Oops. I actually made a mistake here. I said it and I wrote it wrong. Remember when we were foiling this little guy with this little guy? It was a negative sine squared x, and I wrote plus. I know we said it, and then I wrote it wrong. So I'm going to have a 1 minus sine squared x. Okay, so what is 1 minus sine squared x? This is actually going to be something that you're going to use so much in identities. And at first, it's going to be a little bit hard to see it or remember it. But because you're going to use it in so many of the identities, it's going to become more second nature. And what we're going to use here is we're going to use the Pythagorean identity, the main one. What is the main Pythagorean identity? And that is that sine squared theta plus cosine squared theta equals 1. And I can see here that in my version, the squared is being subtracted from the 1. Well, I can do that by moving this over to the other side. So I have cosine squared theta is equal to 1. And when I subtract it, it would be a minus sine squared theta. So what I have here actually is that 1 minus sine squared theta, which is right here, can be replaced by cosine squared theta. So I'm going to rewrite it as 2 over cosine squared. And in this case, the angle is x, not theta. So we have to just stick to our variable. But again, it's just a variable. You could use smiley face if you wanted to. So it's 2 over cosine squared x. And then the last thing I can do to simplify, I'm actually going to make this a little bit smaller now. We can draw an arrow to show that this is what we were doing. I can use the reciprocal identities to change cosine squared. I can bring it up by making it into secant. And we actually already used that over here. Look, this was it. We used it in the previous problem. 1 over cosine is secant. So instead of being a 1 in the numerator, it's a 2, which is fine. And instead of being a single cosine, it's 2 cosines. Which that just means that secant is also going to be squared. If there's 2 cosines, there's going to be 2 secants that come up, and here it is. So this is my final simplification. So I want to talk again about all the steps that we did, because here I believe in total we did, I think, 5 steps. We're going to see. So I'm going to write them down. So the first thing we did to begin is we did a common denominator. And it actually told us to. So that one was. But in the future ones, it won't. You will know to do that because they are 2 separate fractions. And we'll talk about that when we get there. The next one was to combine everything together. Okay? So what you're going to do is once you use your common denominators, you're going to combine, you're going to FOIL. We FOILed down here. I'll do in 2 steps. So we FOILed here. And then in this step here, we combine like terms. Our 4th step, which is down here, which was this little guy, was to use the Pythagorean identity. That's the little blue and green that we did. And our final step was to use the reciprocal identities, which is that 1 over cosine is secant. So 2 over cosine squared is 2 secant squared. So I was right. We did 5 here. Common denominator, FOIL, combine like terms, Pythagorean identity, reciprocal identity. Okay, let's do another one. Another very common tactic that you're going to use is factoring. And you'll see different types of factoring, like factoring sometimes difference of squares, quadratics, greatest common factor, and we'll see different ones of those as we go throughout the videos of both part 1 and part 2. So let's take a look at what we have at the top. So our angle here this time is alpha. Again, it doesn't really matter. You could use a smiley face if you wanted. We can call it A if that helps, okay, instead of alpha. So I'll just call it A, just in case you're not really used to the Greek letters yet. So in the top, we have 1 minus cosine squared. And in the bottom, we have sine A plus cosine A sine A. Now, in the top, we've already talked about this one. It's this little guy right here, what we just did. But instead of being 1 minus sine squared, is 1 minus cosine squared, but it works the same. And I'm going to write it again. Remember, our identity is sine squared theta plus cosine squared theta equals 1. So instead of moving the sine squared theta over, I'm going to move the cosine squared over. And that's going to give me sine squared theta is 1 minus cosine squared theta. So this little guy right here is this little guy right here. So I can change that to be sine squared theta. So that's the first step I'm going to do. So what I'm going to do first, this was on the side, put it on a bubble just not to get confused. I'm going to change 1 minus cosine squared a to sine squared a over. Now in the bottom, I have two terms. I'm actually going to write it again, just to have a little bit more space to explain. So I have two terms here. I'm going to underline them in blue. I have one term, and then I have a second term, and they're being separated by a plus. Ooh, I wrote theta when I had to write a. Let's fix that real quick. It will happen when you're using a lot of different variables sometimes. So in both of my terms there, I have what is called a common factor. They both have something in common. And what they have in common in both of them is sine. And because it's two terms, they both have it, I can factor it out. And what that is called is it's called the greatest common factor. Okay, and it's called factoring out the greatest common factor. So in the numerator, I have sine squared a. And in the bottom, I can factor out a sine a. In the first term, I'll just be left with a 1. And in the second term, I'll be left with cosine a. And then now that I have it in factored form, only then can you actually cancel the signs here. So I can cancel one of the signs in the top with the one that's in the bottom. Because in the numerator, I have two of them, right? Sine squared a means I have sine a times sine a. So what I'm doing is I'm canceling out one of them. So what do I have left? In the numerator, I have a single sine left. And in the denominator, I have 1 plus cosine a. And at this stage, there's not much else you can do with this. We can't simplify it anymore, right? We don't have any more factoring. We have a single fraction. There's no squared, so there's no more identities you can use. So we're going to stop right here. And again, in the future, you're going to see, you're going to be working towards something, so you know when you're going to be done. Here, we're just kind of starting to manipulate. So what did we do? What were the steps that we used to kind of do this? Well, step 1, again, we used the Pythagorean identity. You'll use it a lot, you'll see. Step 2, we factored. And if you want to be really specific, you can write the greatest common factor. And step 3, we canceled. Now, before we move on, I do want to make one note because I do see this quite often, at least with my own students, that you have to be careful where you put the squared. So when you are writing sine squared a, it means that the sine is being squared. This is not equal to sine a squared. In the second one, it's the angle that's being squared. In the first one, it's the ratio that's being squared. It's the opposite over the hypotenuse that's being squared. So you do really need to be careful where you put the squared. If you wanted to put the squared like on the outside, you would then have to use parentheses around the entire sine a. These two mean the same thing. Okay, the entire sine is being squared. But so that we don't have to use parentheses, there's a trick, which is just to put the squared right next to the sine, and that means sine a squared. But do not write the a as being squared if you want the sine to be squared. It's just something for you to keep in mind when you're doing your assignments and so on. So there are going to be a couple of go-tos that you're going to use that you've been seeing throughout this first part of the video that you're going to use when you're doing identities. My advice is to remember these and to write them when you're doing identities. Because for most of the easy to medium identities, which is the ones mostly that you will see, one of these will work. So go-to number 1 is to use the known identities. So we've been doing this already, reciprocal, quotient, Pythagorean. A very common reason to use this, not always, but common, is to change to sine and cosine. And then you will have a common denominator, combined fractions. You saw this. conjugate, you haven't seen this yet, but you will, and then factoring, okay, which you have seen parts of it, but there'll be different types of factoring. Now, I do want to remind you, in case if you forgot what a conjugate was, that's okay. A conjugate is that if you have a two-term binomial, which is like an a plus b here, the conjugate of it is when you change the sign in the middle, a minus b. So they're actually conjugates of each other. So for example, if you have x minus 3, the conjugate of that is x plus 3. Okay, so these are known as conjugates of each other. And you'll see this throughout the thing. Okay, so now let's do actual identity problems. So the instructions of an identity normally is prove. A very common one also is to write show. All right, so you'll prove the identity, show the identity, and so on. So as you can see here now, we don't just have like an expression. We actually have an equation. So we have a left-hand side and we have a right-hand side. The first thing you're always going to determine when you do an identity is which side you're going to work with, because you can only work with one side. And once you have decided on that side, you cannot touch the other side. So I have the left-hand side, which is this guy, and I have the right-hand side, which is this guy. Normally, the go-to is to always work with the side that has more going on with it, because you will be able to manipulate it more. So I think the left-hand side has more going on for it. So I will write at the beginning that I'm going to go left to right. That means that I cannot touch this. It is untouchable now. I am only working with this. And I'm going to do exactly what we were doing before in the previous one. I'm going to simplify, I'm going to manipulate, I'm going to use algebra, and I'm going to try to do this to get it to look like secant of x. So what's the first thing we could do? Now, I will begin by telling you that there are sometimes very multiple ways of doing an identity, and none of them is wrong as long as you're using correct identities and correct algebra, and you are getting to secant. So the first thing I'm going to do here is I'm actually going to distribute. I'm going to distribute the sine of x. So my first step, step 1, is going to take sine and distribute it to cotangent and tangent. So I'm going to have sine x, cotangent x, plus sine x, tangent x. And I'm doing this because I'm distributing. So I'm going to write the reason next to it for every step. Step 2, well, here I have some sine, some cotangent, some tangent. I have a ton of different identities. So what I'm going to do instead is I'm going to change everything to be with sine and cosine. And I can do this by changing cotangent and tangent using the quotient identities. So I'm going to rewrite sine x. Cotangent is cosine over sine plus sine x. And this is sine x over cosine x. And I can do this by using the quotient identities. Okay, so remember that when a fraction, when a number or an expression doesn't have a denominator, it does actually have one that's assumed but not written. It's over 1, okay? So here I am multiplying fractions. In the first one, something nice actually happens. In the first one, the signs can cancel because there's one in the top and one in the bottom, and they're being multiplied. So in the first one, I'm actually just left with cosine x over 1 plus. And in the second one, it doesn't cancel. So I have sine x times sine x. So I have sine squared x over 1 times cosine, which is cosine. This is a very good time to again say that writing it like this would be wrong. Okay, it's not the x that's being squared, it is the sine that's being squared. Okay, so here 3 right here, and what we did here, we just multiplied, right? I'm actually going to save a little space because so we have two separate fractions. Well, what is our go-to when our fractions are two different fractions? We're going to use a common denominator. So in the first one, it's a 1, and in the second one, it's a cosine. So to get a common denominator, I need to change that 1 to a cosine. So I'm going to multiply this one by cosine x over cosine x. Remember that when you do a common denominator, you need to have to multiply to the top and the bottom. Sometimes I do see people writing a single cosine. It's not a single cosine. It's one in the top and one in the bottom, okay? So I'm going to do this and actually multiply, and we can do common denominator here. Okay, so what is that going to look like? I'm going to come over here. The cosine times the cosine in the first one is going to give us cosine squared over cosine x. And the second fraction is not going to change. So it's sine squared over cosine x. And this was still part of my common denominator. And then in step 5, I can combine my common denominator. So actually, this is all part of the same step, technically, so we can... Okay, but we know something very special about cosine squared plus sine squared. Cosine squared plus sine squared is 1. And why is it 1? By the Pythagorean identity. And that's 1 over cosine. So my reasoning here that I did is the Pythagorean identity. This little guy right here. That's the Pythagorean identity. And my last step is, well, 1 over cosine, a secant. And why is it secant? It's secant by the reciprocal identities. And we're done, because that's exactly where we wanted to get to. We wanted to get to secant. Our whole purpose was to get to secant. I highlighted it there. We're done. Yay. So we have that we distributed. We used the quotient identities to change cotangent and tangent. We multiplied and started creating a common denominator. We combined our common denominator. We changed the numerator using the Pythagorean identity, one of them. And then we used the reciprocal identity to change 1 over cosine to secant. Okay, perfect. Let's do another one. Because again, the only way we're going to get really good, practice, practice more and more. Okay, so here we have, again, 1 minus cosecant sine cubed equals cosine squared. So we have a left-hand side, we have a right-hand side. Which one has more going on? The left. So we're going to go left to right. Which means that we are not going to touch this anymore, right? We are trying to get there. So we're going to work with the left until we get to cosine squared. So what's the first thing that we could do here? Oops, I'm writing cosine and I need to write cosecant. So I can see that I have different trig functions there. I have cosecant, I have sine, but I know that there is a way for me to change cosecant into sine, and that is by using the reciprocal identities. So what I can do first is change cosecant into 1 over sine, and then keep this one as sine cubed theta. So I'm doing this by using the reciprocal identities. Okay, so again, remember that this is over 1. So in the numerator, I have 3 of them. And in the denominator, I have 1. So I can cancel this one with one of these and make this a 2. So I have 1 minus cosine, oops. Why am I writing every one wrong? Cosine squared theta. Well, this is one that you've seen. And I remember I told you this was going to be something that you saw quite often, right? Actually, that's right. What we did here, we canceled common terms. So remember that with our Pythagorean identity, I'm going to rewrite it one more time. We have sine squared theta plus cosine squared theta equals 1. If I bring this over to the other side, I get cosine squared theta equals 1 minus sine squared theta. So I have this right here and this right here. So 1 minus sine squared theta is equal to cosine squared theta. And this is true by the Pythagorean identity. And we're done. That one was quick. We like that. This would be considered an easy identity, right? So change cosecant to 1 over sine, canceled, use the Pythagorean identity, we get to cosine squared theta. Perfect. All right, let's do another one. Okay, so here I would say that the left and the right, I mean, they kind of have both going on, so you could go either direction. I'm gonna go left to right, and actually I think this is our last one. Yeah, I can even show you actually how to go right to left, just to see, because sometimes, like I said, there are multiple ways of doing identities. It's like a puzzle. So I'm gonna begin by doing left to right. Okay, the first thing I'm gonna do is I am going to see that on my left-hand side, I have cosecant and cotangent, but on my right-hand side, I have sine and cosine. Even though I can't touch my right-hand side, I should be looking at it, right? I know that that's where I want to get to. I know what the answer has to be. So I'm going to change everything to be in terms of sine and cosine. So step 1 is I'm going to change cosecant to be 1 over sine x, and I'm going to change cotangent to be cosine over sine. And I can do this because I am using the reciprocal identities, one of them, and one of the quotient identities. Okay, step 2, I see a common denominator. Like, it's already done for me. So I can combine these fractions into a single fraction with a common denominator of sine of x. So I can do this because I have a common denominator. I didn't even need to create one. It was already there. Okay, so I have 1 minus cosine x over sine x. And what I'm trying to get to is sine x over cos plus cosine x. And so this is going to be the first time that we do this here, so it would have been probably hard for you to recognize it right now when you're beginning to know identities. For me, it's a bit easier, but I can see that where I am now and where I want to be has the conjugates of each other. So 1 minus cosine x and 1 plus cosine x are conjugates of each other because the sines is the only thing that's different in the middle. So what I'm going to do is I'm going to use the conjugates, and the way that you do that is you take the expression that you have and you multiply the top by the conjugate and the bottom by the conjugate. Okay, because what I do to the top, I have to do to the bottom. So I'm multiplying here. And here what I'm doing is using the conjugate. Once you use the conjugate, you want to FOIL the conjugate part, which means that you want to FOIL the top. And I'm going to use little arrows. So remember, FOILing means that you distribute the first term and then you distribute the second term. So 1 times 1 is 1. Oops, I want to do black. 1 times a positive cosine x is a positive cosine x. So here I distributed the blue arrows, and now I'm going to distribute the red arrows. So a negative cosine x times 1 is a negative cosine x, and a negative cosine times a positive cosine is a negative cosine squared x. This time I did the negative. Over. And in the denominator, you're gonna leave it as is. You just want to take care of the conjugate for now. So you're going to simplify that. Well, these two cancel because 1 is positive and 1 is negative. So we're left with 1 minus cosine squared x over sine x over 1 plus cosine x. Well, now we have 1 minus cosine squared. We've used this. I think this is going to be the 4th time we use it now. So remember that 1 minus cosine squared, because it's a minus and the cosine is being squared, I can change this to sine squared x over sine x over 1 plus cosine x. And I can do this because of the Pythagorean identities. Okay, I'm going to go up here. Step 5. Well, I can see that I have 2 signs in the bottom and a single sign at the, 2 signs in the top and a single sign in the bottom, and the bottom is factored, which is how I can cancel. I actually have a special canceling video about when you can cancel in fractions. So if you are looking for that, just put canceling in fractions and you'll find the video if you feel like you have a little bit of a hard time with that. You can cancel one of these with one of these. And so at the top, I have a single sign left. And at the bottom, I have 1 plus cosine x. And what I did here, honestly, is just to cancel. But that's exactly where I wanted to get to. That was it. Sine x over 1 plus cosine x. Yay. So it's done. Okay, as a bonus, I am going to do it the other way just to show, because I think it's good to show different ways of doing identities. So here now I'm going to go right to left. So now I'm actually going to start with this one. So actually your first step that you're going to do for the right side, because there's not much, you can't change to sine and cosine, it's already changed to sine and cosine. You can't do a common denominator because it's already a fraction, single fraction. You can't factor, there's nothing to factor. So really the only thing here that you can actually do is multiply by the conjugate. So your first step in this one would be directly to use the conjugate. So you would begin by using the conjugate. So in the numerator, you would leave it as is. In the denominator, you would FOIL. We already did that in the previous one. Remember that when we FOILed, we canceled, and we were left with 1 minus cosine squared x. Then you would use the Pythagorean identity to change 1 minus cosine squared x to sine squared x. So very similar kind of identities that you're using as the other one. You're just kind of doing everything in the opposite direction. Then you would cancel. So one of these cancels with one of these. And you can do this because it's in factored form. So I would have 1 minus cosine x over sine x. So I just canceled here. And then this would probably be the trickiest part for some people to recognize. I can do this because I have a single term in the bottom. And what I do is I do the opposite of doing a common denominator. I split the denominator. So what I do is I actually write 1 over sine x, and I write cosine over sine x. I can do this because there's only one term in the bottom, right? So what I'm doing here is I'm splitting the fractions. And then 1 over sine x is cosecant x, and cosine over sine is cotangent. And that's exactly what I was trying to get to. Yay. And I do this, again, by using the reciprocal, and quotient. So I do think in this one, left to right would be a bit easier just because of that fourth step. Some people might get stuck in that fourth step. Where would I go next? But again, some of you might actually prefer this. So I just wanted to show both. So there's a part 2. We're going to do more identities because we just need to keep practicing.